Hi everyone, my name is Marlene and welcome back to my YouTube channel. In today's video, we are going to be building a deep researcher using DeepSeek R1, LangGraph, and Streamlit to build out the front end. You have probably already tried out deep research in ChatGPT, and I have personally found this feature to be really useful if I am trying to do some in-depth research on a specific topic and I want the most relevant and up-to-date information as possible. It produces a really useful report, and I think online I have seen loads of people talking about how they think this is one of the best features that OpenAI offers. So this is what we are going to be building out. We are going to be using an example from the Langchain team where they've built out a completely open source deep researcher, but you can really use a model of your choice. I'm going to be switching this up a little bit. I'm going to be using DeepSeek R1 as our core thinking model, reasoning model, and then I'm also going to be using GPT-4o for some of the other parts as well. So if you're interested in any of this, please keep watching. Okay, so the first thing that we want to do is to navigate to GitHub. We are on the local deep researcher repo from Langchain. It's just in the Langchain AI GitHub. And this has information for us in the README about how this researcher works. So the first thing is that we get in a topic from the user. And so that topic can be, anything that the user decides to put in. And then from there, you're going to generate a search query. So you're going to use an LLM to take that topic and generate a search query based on that topic. And then we're going to use a web search tool. For our example today, we'll be using Tvili. After you've gotten the results, then you want to create a summary. So the initial stage is actually creating a summary based off of the results you got from the internet. And then finally, after that, you are going to take that summary that you've created and send it over to your reasoning model. So whichever model you're going to use, we're going to be using DeepSeek R1, which will reflect on that summary and think to itself, are there any gaps, knowledge gaps in this summary that need to be filled? And then where it identifies knowledge gaps, it's going to generate a follow-up query that it will then send back to the web search tool to be able to look online for the extra information that it needs. So that's going to happen in a loop. And we will have a conditional edge that will run the research a maximum of 3 times before it then generates the final report. If we go into the source folder, we can look at graph.py, and this has a lot of code in it. It has, I want to say, 5 key nodes. I found, one of the things I will say is that in this project, it's such a great project, and they do give you a lot of optionality. So they have some if statements here in the code that allow you to choose whichever web search API you want to use, or they also have code to be able to allow you to choose which LLM you want to use, whether you want to use Olama or whatever it is to connect to the LLM, the specific LLM you want to use. I have changed to that a little bit just to make the code a little bit more understandable for us. And so I will change that. And so I'm not going to clone this repository. I have taken out parts of it. And I will say that I'm going to use the state.py file, the prompts.py file, and some of the functions from the utils file as well. So just to demonstrate what I've done, I'm going to navigate back to my editor. And here in my code, I have a folder in my VS Code. I have a folder called Deep Research. And in that folder, I have my virtual environment that I've called Deep Research. I have a requirements.txt file. I'm going to be using Langchain Azure AI to be able to access our DeepSeek model. I'm also going to be accessing GPT-4o just to be able to speed things up with some of these things like generating the query. I don't know if we need to use thinking model for that, but I think you can experiment with these things and see how it goes. I'm also going to be using Langchain and LangGraph, and I'm going to also use python.env, markdownify, and Tvili to do the web research. So Let's start by pip installing. Let's go ahead and pip install our requirements.txt. And that should just go ahead and install all the requirements for us in our virtual environment. That was quick because I've already done it before. And then we can take a look at our Jupyter notebook, which is where I've pretty much just simplified the code that was in graph.py and put it into this Jupyter notebook form. The first thing that I'm doing is I'm importing Azure AI chat completions model from Langchain Azure AI. And this is just going to allow me to access my different models here. This is what it looks like to access DeepSeek. I'm also going to access GPT-4o to be able to generate the query and to create the initial summary. And then I'm also going to be creating an images, just a list for images, because I want to include images in my final report as well. So let's run this, and that should just run as expected without any errors, and that's fine. The next thing we want to do is we want to go ahead and build out our agent that is going to do this deep research for us. And for that, we are going to be using LangGraph, like I mentioned. And LangGraph allows us to create these state machines or just graphs that will enable us to either update or preserve the state of our different inputs. And we do have a state.py file that I just took directly from the repository. And the main state that we will be passing around is the summary state. So the state is just going to be this class, and you can access different these different inputs through the state. So we have the research topic you can access or update, search query, web results, sources gathered, and the research loop count, and then a running summary. So we're actually going to be checking how many times the research has been done. For that example, we're going to set that at limited to 3. So once it's hit 3, it needs to break out, stop researching, and then create the final summary for us. So if we go back, let's go ahead and define. So I want to say, let's define the nodes and edges. Before we start, I would like to just say one way when I was talking to my teammates about this, one way I kind of like to think about nodes and edges is that with nodes are typically the Python functions that are going to update the state in one way or another. So if we go back to the state .py file, maybe we have the web research results. So we will need a node that will run some web research and can alter the web research results. So it will add new results to it or replace the results with things like that. Whereas an edge is just going to be something that is going to direct the states from one function to the next. So you can have a conditional edge, which has another function that makes a decision on which direction to send the state. But typically how I'm separating the two in my head is that nodes are going to update or alter the state in some way usually, and then your edges are not going to alter the state. Your edges are going to make a decision on which direction your state is going to go. So hopefully that is helpful to you, like it's been to me in terms of differentiating the two. So the first thing, like we talked about, is that we want to have our first node is going to be a node that will, let's say node 1 is going to be generate query. And for that, we can go ahead and do this. I don't know if this is correct, but let's leave it. I'm not sure. Copilot is giving us some code here. I'm probably going to change that code, but let's leave it for the moment. And then I will come back and just copy and paste from the example in the repo. Then the second one we want node 2 to be our web researcher. And so in this case, we are going to def web research. And again, it's not going to take, I'm not sure why. It's not taking the message state. I'm not sure. I just realized that we are only passing through the summary state because that has everything that we need in it. So I'm just going to replace this here. And then we will be able to I just feel like a lot of this, I don't really know why Copilot is suggesting some of this code. I will come back and edit this code. But it's kind of getting it correct, but it's just like slightly off, if you know what I mean. And then after this, the next thing that we want to do is we want to summarize those web results. So let's say I want to put a note in front of summarize web results. And then let's call this def summarize sources. And then that's going to take in the state of the summary state, another node, which is going to be our node here, which is going to be our reflection node, and that is going to reflect on the summary. So this is the correct name of the node. So I'm going to let it autocomplete that. And then the fifth node is what's going to be used to define, def. We're going to actually finalize the summary here. Okay, so that is pretty much what we need for our nodes. I'm gonna put in, this is node 5, and that's going to be to finalize the summary. Good. So these are the core functions. We have 6 functions, which is a lot to be able to write out all of them, but these are the main functions that we need to be able to actually carry out our deep research. See here, we're starting out with the summary with this generate query function, which is our first node, and it will access the research topic. It's going to use this query writer instructions, which we imported from prompts. And if you look here, it's just a Python string, and it sends in the current date and the research topic from the user. And then it tells the LLM that your goal is to generate a targeted web search query, gives it some other things, and tells it to give its final response as JSON with the query and the rationale behind why it made this query. And so that's what's happening with our first function here. In the web research node, we'll then take that search query that we got from the generate query and then run Tavili to be able to look online. We're limiting the maximum search results just for this prototype to 1, but you can increase that. We can also decide whether we want higher quality results. There's an option in Tavili to do that, so you can edit that as you'd like. And we're going to use this helper function to deduplicate and format the sources as well. And we'll include all of that there. So let's go ahead and also load this function. That's node number 2, like we said. Node number 3 is going to be summarizing the sources that we just got from the web researcher. So here we're going to access the running summary. When we're starting that, we don't have any running summary. So that's not going to return anything for existing summary, but we are accessing our web research results. And if there's a summary, we give it the existing summary and the web research results and tell it to generate a new summary from that. But then if not, we just send in the web research results and create an initial summary from there. And then we invoke the model to just generate our full summary with that input that it has. So based off of the web research, the existing summary and the research topic is what we're using to create that summary. Then, so this is our node number 3. I'm going to make sure I'm just loading these in as I go. And then the fourth one is going to be our reflect on summary function. That's our fourth node, second last one. And here, the main thing it's getting is the research topic, and it's also going to get the running summary that was generated from our previous function. And it's going to say reflect on our existing knowledge and now identify a knowledge gap and generate a follow-up web search query. So this is where we're definitely going to be using DeepSeek to be able to reflect on this. Once DeepSeek here, so here's where we're invoking the DeepSeek model. And then once it's actually given the results back, we're stripping the thoughts out and getting the thoughts in a separate option there and the text, then we can load in the results and it should give us the follow-up queries. Our finalize summary function is the final node that we have. And this node is just going to access that running summary. It is going to then add the sources at the bottom of that running summary to give us the final output. And that will be it's not really changing anything. It's just making it into this nice format and in Markdown so that it can render with Markdown. And then here, this is our conditional new node with root research. And that's going to be counting the number of research loops, which we saw in the web research part here, where it's going to be adding 1 to each research loop count once web research is done. And if that is below 3, it will call web research again. So it'll go through that web research part and run the whole process until it gets back here. Once the loop count is over 3, it's going to exit that and then finalize the summary. This should be pretty much ready to go. I am going to be streaming the outputs. I could put graph. So once you run compile, graph builder.compile. So this was the state graph that we initiated here. And once you've added all your nodes and you've added all your edges, you can put .compile here, and that will create a graph that is ready to use. And then you can just call it like you would in Langchain with any option like stream or invoke. Because we're using stream, I'm going to say for, it's going to create a generator for us. So we're going to say for event in the stream. And then we're going to pick out the different things we want to print to the screen. So I want to see the query that's being generated. I want to see the research. And I want to see the final summary that's being generated as well. So these are the things that I'm going to have printing to the screen. And I also put in a print statement for the agent's thoughts because I want to see those as well. So let's press play here. And then I'm asking the question, what are the best parks in London for the summer? It is the summer right now. So I think this is critical research for us to be able to do. And we're loading that into a function there. And we should see the results. The results we can see best parks in London to visit during summer 2025. You can already see the query is different from the user input because it's added in the current year. So it already has, created some improvements to the user input because it's going to get the most relevant results. We see the source gathered. This is the source. Remember, we only asked for one source. And we also didn't include all of the raw content. So you can do that if you want some detailed information from the returned information. And we limited the tokens from the returned result to 1,000. We can see the agent is thinking here, and it says it mentions Hyde Park as a top choice for summer in London, highlighting events. Here, however, the summary also notes other parks renowned for their summer ambience and recreational spaces weren't detailed. So it's thinking about the right things, and it's saying the main knowledge gap here is a lack of specific information about knowledge gaps. So it's going to generate the next query based on that. So we're going to do some more research here. We're seeing some different links. The first link was this Londonist one. The second one was the Family Kids News London Park one. Something I will note is that I did notice that sometimes there is a repeat of the last 3. I'm not sure if it's because it finds the correct information now in this article or that it wants more information from the article because it only had 1,000 tokens. But I'm seeing this as like a little bit of a flaw in terms of the research, which I'm going to look into and see how to fix that a little bit later. So this is pretty much how the back end of this application works. It's quite a lot of code, but it's definitely doable and understandable if you're able to walk through everything. Now, I do want to show you. Okay, so final thing that I wanted to show you is this quick demo for building out a researcher. And I built this using Streamlit. Super easy to build and pretty easy to implement. You can go ahead and click Start Research. I will mention that I will put all of the code for this in the links below. I am just going to share the code. It's not perfect. There's some issues. I have been doing this myself as well as vibe coding a little bit, but I will be updating this as I get the time to. But you can see it's repeating the word sources and AI thoughts, for example. I can easily update that. But yeah, you can see this is the running summary that's being updated. We're seeing the sources that are being generated. It should be putting some progress in this research bar here. Like I wanted to monitor the number of loops and that to show the progress there. We are seeing the thoughts from DeepSeek being rendered to the screen, which is great. And yeah, the updating of our different summaries is being updated to the screen there. I'm not sure if I'm going to keep it like this because I don't know if we need a new section for each updated summary. Probably not. I will be giving a talk at Microsoft Build, a workshop about this at Microsoft Build. So I think I will be working and improving this example. But yeah, this is the final outcome. We can see this beautiful image that has been rendered out for us. We can see all of the sources that we need. Here's our final summary. It's making some recommendation. Battersea Park is by the River Thames, St. James Park as well. Lots of nice parks by some rivers. That was what I asked for. So I think that is correct. And we have all of the sources that we need there. Like I mentioned as well, we're getting some repetitive sources. Not really sure 100% how to deal with that issue. But I'm going to experiment a little bit more and see how it goes. But I think for the most part, this looks really great. That is going to be it for today's tutorial. I hope you found this useful. I think there's loads of ways you can update the code and tweak it so that it is working the way that you would like to. I know I am going to be experimenting with this and we'll try to improve the code as I go along. I will leave all of the links to the code and the repository in the description, like I mentioned. If you enjoyed this video, please give it a thumbs up and subscribe to my YouTube channel, and I will see you in the next one. Bye.